platform, but it could also be utilized for data at rest, how it can be actually provided in a stream in a pub/sub mechanism. So we look at that in use case 2 for financial data fabrication. And in the use case 3, we look at real-time sensor data. So it's more on the IoT part, what one of our clients actually is using for. Then we look at why we look at DataTorrent RTS for this kind of a particular use case where we read from Kafka and write to HDFS. In between, you could actually do your customization. And I'll just take some questions at the end. So moving to the next. So effectively, there are two operators in this particular application template where we have a Kafka client which is reading from version 0.8 or 0.9 depending upon what you have installed, and it's based on the topic what we are reading from. We're writing depending on what file format it would be providing. It would be a string or any kind of comma separated or a JSON or an Avro. It could be written directly to an HDFS output operator. So this is effectively the template where you could actually just configure the properties for the Kafka client and the properties for HDFS output, and just read the messages from the queue and write it to HDFS in the desired location. So a little bit brief about Kafka. So what exactly Kafka is? It's one of the most prominent distributed messaging system in the Apache ecosystem. So if you look at the history, it kind of originated from LinkedIn, and the guys over there were basically trying to develop a distributed mechanism of offloading data where they were reading from different sources as such, where they could utilize it from their own purpose. So the team from LinkedIn actually then, when they started developing it, then they realized that this could be a much bigger thing, and they came out of LinkedIn and formed Confluent, which is now contributing mostly to Kafka. It's basically based on fast reads and writes of logs. So when we say a topic, I'll cover this part in the next slide or so. It's basically based on the concept of a write-ahead log kind of a thing, which people are writing their so-called messages into this log structure. So there is a publish mechanism where the producers of the data are actually publishing this data into this queue, and on the other side there is a consumer part which actually reads from this particular queue. So it can handle a large number of clients in a very scalable, fault-tolerant, and partitionable manner. So the other important part is it actually uses persistent message, so it writes data onto the disk. So that's how it is fault tolerant as well. So it ensures that there is no loss of data once it is published on their cluster as such. Any questions? So continuing on the terminologies of Kafka, so basically if you look at this diagram, mostly what's taken from Apache Kafka itself. So it's a pub/sub mechanism. It's a publish and you subscribe to that particular data on the consumer side, where there is an API where producers of the data can actually use this API to publish their data. So each of the record, you can say, is basically handled by a key, where all these keys are actually kind of categorized into a message identified by as a topic. So there could be multiple such topics for which producers could be writing data. In between, there's a concept of broker, which basically, so Kafka runs over a cluster. You could run it as a single node, single broker cluster, or a single node, multiple broker cluster. So think of a broker as a serving layer to the consumers and the producer. So which producer should talk to which broker, and then ultimately on the consumer side, which consumer or the group is basically reading the data from which broker. So it's kind of brokers are connected to the nodes in the Kafka cluster, the way the cluster is deployed. So on the consumer side, there could be one or more consumers for a particular topic. Their data could be read in through a Kafka client, and through this Kafka client, you could actually write this data into your desired persistent store. So it could be a file system like HDFS, or you could actually write it to a SQL store or a NoSQL store, or any kind of other storage mechanism that you might be using in your operational scenario as such. So this is what the brief. I just wanted to touch base on Kafka. So moving on to the use cases. So one of the prominent uses, so Kafka, when we look at publish subscribe mechanism of reading data, where there are multiple players who are actually publishing their data over a layer, and on the other side there are groups of consumers, entities you can say, who are actually reading different types of this data. So in one of the use cases that we have come across, one of our clients, it's actually reading ad logs. So log events basically consumed via Kafka from different regions. So they were basically on AWS, where they had different servers who were actually publishing all of these log events. And the idea over here is this particular entity is serving their customers who actually run some kind of a campaign analysis. So they wanted to understand what kind of ad impressions they are seeing, and accordingly look at their strategy of how they would like to go about publishing ads using our clients' technology, as well as a real-time dashboard being provided to their clients, where they could actually see what's happening with their ad campaign and make changes. So in real time, they could actually make changes where if let's say this layer of Kafka was not into the picture, they would have to collect this entire data over a period of time, look at the data, do some in-memory computation. So they were looking at different kinds of aggregates like averages, means, variances on different types of the events, and ultimately they would have taken a decision. So imagine a scenario, the same picture, and you take Kafka out of this picture. So from each of these regional services, so the biggest job for this entity was to actually collect this data from these geographical regions, which itself is a difficult task, and then doing the computation, which was not happening in memory at that point in time. So it would take significant time for this entity to actually collect this information, calculate the aggregates, and then provide this information to its customers. So effectively, what could have been done in hours was taking a long time. So this was a challenge that they were facing. So in collaboration with Kafka and our platform, the DataTorrent RTS, they actually managed to deploy this, collect the data in as real time as possible from different geographies, perform in-memory computation. So here we are not doing any OLAP kind of queue analysis, but mostly in-memory calculation of averages, means, variances for each of the log events that are collected via Kafka. And for their end customers, they were actually publishing a real-time dashboard. And also certain part of this data was going for an application that was utilized for to understand the strategy for ad placements based on the metrics that were computed, and to persist this particular data. So this reduced a time from, let's say, a day to almost like a couple of hours. So that was the gain that they had by actually putting Kafka with DataTorrent RTS. If there are any questions, I'll just take it now for this use case. Okay, I'll move ahead. So this is the second use case that I was mentioning earlier, where I wanted to focus that it's more like a batch scenario. But the interesting part is the way this entity or our client actually utilized it. When they said that they had different SMTP logs, they had some financial application data, they had some historical data that they had to provide to different applications in their infrastructure as such. So when they were talking about this, we did suggest them that even though Kafka is a pub/sub mechanism and more suited towards real-time or streaming data, they could take this data and still play it for their application over our platform, the DataTorrent RTS. So what they eventually end up doing is they place the layer over there. They started reading data or publishing data to these applications. This was mostly customer data of the bank. So based on the geography, they had compliance issues where they could not publish data in just an ASCII format. So it had to be encrypted, and it had to pass through some compliance rules where it could check whether the data has been properly masked or not, and also raise certain alerts if it found any errors on the data. And that encrypted data would then be served to the different applications. And some of this data was archived, and most of this data was also persisted on a store, on basically on Oracle. So this was a secure, fault-tolerant way of ingesting data before their end stream application or other downstream applications could actually utilize it for further analysis as such. So just this part of the ingestion was used in a very fast way, where they could just publish this data with some processing in between in terms of masking, encrypting the data, checking for the encryption based on the compliance rules, and alerting to these applications. So the DevOps could actually do a lot of things with just this application to ensure that they serve the right data to the right end stream application. So next use case is one of our clients has been using our platform DataTorrent RTS in collaboration with Kafka to read sensor data. So now we are talking about the Internet of Things. So this is a heavily talked about use case in the industry, as well as people who are interested in the domain as such. So effectively, they were looking at high performance, multi-customer secure data ingestion. And in between, some complex event processing was involved. So they had to do some predictive maintenance. So to give you the example of their own use case, so imagine certain aircraft engines. So in different parts of the engines, there are certain sensors that are placed, which generate a lot of data on a regular basis. This entire data is being collected, is actually passed through. So there's a governance model, there is a complex event processing model, which actually takes this data. There are certain rules that are applied over there, and it actually pushes the data to their predictive maintenance module. So this is one of the use cases where they would actually continuously collect the data, apply certain rules on top of it, and to go for a certain scoring model where they could actually predict whether the part needs certain kind of maintenance before they actually go for a physical check. So this was kind of an alerting mechanism where it would be displayed as part of an application, and this data would be served to various other applications based on the business need for that particular data. One of the key things was to just quickly get an alert whether a particular engine needs immediate attention, or rather predicting it when it would actually require for it to be looked into. So this was heavily used by their heavy machinery engineering team, and this is how they utilized the Kafka. So on the producer side, based on this sensor data, the topics were arranged accordingly, and the partitions were done, where data was being written for each of the sensors. And on the broker side, with the help of the Zookeeper, all these applications kind of were reading with this complex event processing into place, and then utilizing that data for their internal analysis. and part of this data was also sent for persistence. So any question regarding any of these three use cases that I can take as of now? Okay, I'll move forward. So now, coming to our platform, so why DataTorrent RTS? So why should this particular platform be used, given there are other platforms into the streaming world as well? So here are some of the answers why exactly we should look at it. So given what our clients have been doing with our platform, so it is powered by Apache Apex. So it's an open source, top level project, where a lot of contribution is happening from outside and especially from DataTorrent. Some of our customers are also contributing to this particular platform. So there's a lot of evaluation in terms of streaming terminologies within this platform. Over the last 4 or 5 months, we have seen quite a few things happen in the platform, which is available openly to people. They can actually see what's the roadmap of this particular platform. In-memory processing. So be it a real-time streaming or a streaming scenario, or be it a batch scenario, we make sure that we play the data, we actually process it in memory as far as possible, unless until there is some custom logic involved in your application which actually writes to disk and then reads it. So the platform ensures once the data is given to it, it all flows through in memory. So ensuring low latency and as high throughput as possible. In addition to Apache Apex, there is a library of operators of basically business logic that has been defined as specific functions, which can be taken from this library and connected together to build this kind of an application. So these are reusable components provided as part of the Apex Malhar library. In Apex itself, there is a built-in fault tolerance and scalability. So it ensures that if, let's say, the application crashes, so for example, harnessing on power of Kafka, let's say in this scenario. So if Kafka provides the data, so Kafka itself is, let's say, fault tolerant. On top of that, if it's providing real-time data, if the application happens to crash, or let's say your node goes down or something happens, RTS, which is powered by Apex, will elegantly bring it back, ensuring that there was no data, basically bringing it back from the last checkpointed state. So we checkpoint at various stages of the data processing to ensure that there is no data loss from the platform's perspective. In many of the scenarios, we've seen that applications have been written by our clients, our prospects, and they have deployed it in a certain manner, and because of certain inbuilt logic within the application itself, it tends to crash because of the unavailability of certain resources at time. But Apex still brings it back from a state, and without them even being aware of it. In terms of scalability, so it depends on how much of data is flowing, how much of utilization of the resources is happening. So if not much data is flowing, so Apex would not consume a lot of your resources. It will scale it down. Accordingly, based on the partitioning that you've done for these operators or the functions within the application, it would actually scale out or scale in depending upon the availability of the data. Ease of development. In Apex, or rather in DataTorrent RTS, you could actually go and quickly just, all you need is basic Java development expertise, where you could take these Malhar components, just plug them in, put your custom logic into, you can create your own operator as such, so what we call it as a directed acyclic graph, where you could actually read data, perform complex algorithms on it, and actually write it to some store, which could all be done just by connecting these operators as a directed acyclic graph. It's as simple as that. So the ease of development, when I say some such kind of applications in a previous past would take like months to actually do, you could actually get it running in days. So that's the reduced time of production that we talk about when we talk about DataTorrent RTS.
couple of questions. One is, how is real-time data processed on data written in Kafka? And the other one is, how does it create checkpoints at platform level? So I can answer that from an Apex perspective. Basically, when the data is written in Kafka, the Apex has input operators which will fetch data continuously, polling Kafka for all the topics that are configured, and then it will pass it on to the next operator, or the downstream operators as we call, or the processing unit. So whenever you have new data coming into Kafka, it is immediately pulled in by the Apex application that is developed for this purpose, and in process that way. The second question is, how does it create checkpoints at platform level? This is pretty much we will be covering next time for sure when we'll be discussing this application in detail. But I can give you an overview of how it happens. So the checkpointing is a asynchronous process in Apex application. So there are different functional units that are working in a distributed fashion in the cluster. Then each of this unit periodically does a checkpoint. So we have a concept of windowing. So after every 60 windows, that is like 30 seconds by default, all the operators will checkpoint. Now the checkpoint, the point is the first operator is quite fast in terms of processing the windows, and the second one will follow the first one, the third one will follow the second. So that's why this checkpointing is not synchronous, but it is done asynchronous, and every 30 windows it is checkpointed. And once you have all the windows for a checkpoint done by an operator, then we sort of commit it. We say that this state is now across the DAG is consistent.
So for that application, what Sandeep is mentioning is as each of the operator goes through these checkpointed windows, they commit for that particular state. So it happens to be that current state of that particular application. So if it goes down, it tries and brings it from this committed state. So there is another webinar which is planned on Wednesday, November 9th, where we'll be actually deep diving into this application template, which basically reads from, so there's a Kafka client operator, which is writing to an HDFS output operator. So there we'll be covering most of these aspects in further details. So guys, that's what we had for this particular session. Really thank you all for your time, and my apologies for this confusion that happened. Yeah, I think there's another question from Priyanshu.
Let me check. Thanks for clarifying. No, the others are about the time and other part.
Okay.
The next question is, hope operators are specific to topic or message. Let me take this up again. So basically, the input operator, the operator which connects to Kafka is called the input operator, Kafka input operator, and there you can set it up as per the topic or even the partitions. So you can have one operator pulling in all the data from all the partitions. So there are topics and then partitions. So one topic can have multiple partitions. You can define the mapping whether you want one operator to pull in all the data, or you want one operator instance to pull in data from one partition. So that configuration is directly possible using the Kafka operator. There's no code change, just a configuration parameter.
So guys, these are some of the resources that you could probably look at for Apex. and you could subscribe to our community where you could, if you have any answers or questions with respect to this particular template. So there is a user forum which you could actually subscribe to. With respect to our platform, we have certain startup programs for enterprises who are just new to the ecosystem, or there is any university program that you might be interested. Please feel free to write to us. And so the next webinar, as I mentioned, is on November 9th. Again, apologies for this time. I'll confirm the time. We'll update the right time on the meetup page. But again, I think it's the same time at it's at 7:30 a.m. Pacific time, which would be 9 p.m. IST. Apologies for this incorrect information over there, because we just didn't remember the daylight saving. Thank you all for your patience. I hope this has been a little bit of eventful evening for you, where we could explain things about Kafka and how our customers have utilized Kafka in their applications. So this session is not particularly about the details of Kafka. That would require more than this time if you really have to talk about Kafka in details and or about Apex. So there'll be further webinars in the future where we can talk, where we'll be looking at the platform. You can look at YouTube. There are quite a few webinars that have been conducted in the past. So if you go to our meetup sites, you can see previous topics as well. Plus on the YouTube, you'll find quite a few YouTubes of previous webinars that talk more about our platform. Any questions as such? So guys, thank you a lot for your time again. Unfortunately, we have to still carry on because we have to wait for people from the US to join us. But if anybody is in So guys, we'll start with this particular webinar as part of this series. We will be covering quite a few application templates. Again, as I mentioned, these application templates will be provided as part of our App Hub module of the DataTorrent RTS platform, which is powered by Apache Apex. And again, to reintroduce myself, I'm Mohit Jotwani. I'm part of the product management team at DataTorrent, based out of India in Pune. So let's look at the agenda for this particular webinar. So you look at the application template where we have an operator which reads from Kafka and basically writes to the HDFS store. A little bit of brief on Kafka. And then we kind of deep dive into these three use cases where some of our clients have actually utilized the power of Kafka with our platform for these three cases. Then we talk about a little bit why exactly they went ahead and used DataTorrent RTS. At the end, I can take the questions, but however, feel free to post your questions in between. So the idea over here is this is not a deep dive session into Kafka or as such into DataTorrent RTS or Apache Apex, but to actually give you an idea as to how people have been utilizing these technologies in the Apache ecosystem as such, and how Kafka has been utilized by our clients in collaboration with our platform. So as part of the template, what basically would be provided on our app would be a basic Java app package, where there are two operators. So these two operators are part of our Apache Malhar library. So the first one is a Kafka input operator, where it's basically a Kafka client where you just have to configure things such as the topic, the cluster, the zookeeper configuration as such, to read data for a particular topic based on a particular partition offset. And then these template basically then writes this data. So the data could be coming in any format provided from the cluster, the Kafka cluster, as a string or as a JSON or as Avro, being written to HDFS. So the beauty of this template would be, if you would like to try it out as part of any application that you would like to build using Kafka and HDFS, you could actually take this Java package and just plug in the configurations for Kafka and your HDFS or Hadoop cluster. Basically, what you would require for this particular application is our platform, our DataTorrent RTS version 3.6, which actually runs on top of Hadoop 2.2 plus. Any distro is fine. So basically, Apex, which powers RTS, requires Yarn for the scheduling. And the other thing that you will basically have to do is have your Kafka cluster and the Hadoop cluster in place, and you just have to configure the properties. So based on the use cases that we'll see later on, you can see what kind of further customization that you could do to this particular template to actually make it a full-blown production-ready application. So brief about Kafka. So Kafka, those who have already looked at Kafka in the ecosystem, is basically a distributed messaging system. It's a what we call as a publish subscribe mechanism of providing data from the producer side. So there is a producer API which basically allows different data producers to write data. So effectively, in the background, what happens is it's kind of a write-ahead log which is being written into a queue. Where each of the data that is written, which is kind of read as a message, has a key, and all these keys are attached to a particular category which is called topic. So in the next slide, I'll talk a little bit about that. So known for its fast reads and write, where it can handle a large number of clients. So Kafka is a mechanism where people are publishing data, and on the consumer side, there are quite a few players or entities or applications which are actually subscribed to these topics, where they are reading from these topics based on the partitions for their data. It's scalable, it's fault tolerant, and it's partitionable. So when we say fault tolerant, so Kafka actually persists data on disk. So it actually writes these logs on disk. So if you happen to lose a node, or your cluster, something goes wrong into the cluster, so the zookeeper will ensure that it provides you the data. So this is the beauty about Kafka. So some of the terminologies that you might come across when people talk about Kafka. So there's topic. So topics, nothing but the category for which these messages are published by a producer, written to the cluster as such, and which are then subscribed by end consumer, which could be an application or a client that you might have written, like a Kafka client, what we have written in this case in our template, which actually reads from these topics which are partitioned. So you could actually go to a particular topic and actually read from a certain offset or a partition actually. So producer and consumer are nothing but APIs that have been provided by Kafka. So a little bit of history on Kafka is it actually originated from LinkedIn, where they were looking at more of a distributed messaging system, rather a distributed system as such, where they had to take data from different sources and provide data to different end application as such. So as a result of what happened in LinkedIn, the team which was working on it got pretty excited, and they came out of LinkedIn and formed their own company, what is called Confluent as of now. So this is what they have given to the ecosystem. So in between, you see the term broker. It's nothing but the set of nodes in a Kafka cluster. You can think of them as brokers, or rather a serving layer between the producer and the consumer. So whatever the producer publishes, the consumer is not aware of that unless it subscribes to that particular topic. So producer basically talks to a broker in a node, and the consumer is like an application which basically subscribe to a particular topic that is provided, which provides the messages as such. So there could be different ways of actually deploying a Kafka cluster. So I won't be covering all of that. It could be like a single node, a single broker, a single node, multiple broker kind of deployment of the cluster. So here, what I'll be focusing more is on the use cases where some of our clients have actually utilized the power of Kafka with our platform, DataTorrent RTS. So a messaging system, especially a PubSub kind of messaging system, is mostly seen from a real-time data streaming scenario. And one of the key areas where it's prominently used is in the ad world, the ad tech world actually. So one of our prominent customer actually had this problem where they were reading a lot of log events from different geographies or different geographical regions served by AWS. So they had to read all of these log events, and they had a requirement to do a lot of aggregation on this data for different events. So a lot of aggregates such as average, means, variance, based on which so basically it was an in-memory computation. So it was not an OLAP cube kind of a thing, but mostly in-memory computation of these events that were happening, which were serving a real-time dashboard which was given to their customers, and an application which was kind of an ad strategy placement application where they would actually go and talk to their customers and tell them about how they have been serving them. So if any campaign analysis based on the ads that have been placed using their technology, so they would actually look at this dashboard, and they would go to this application where these metrics have been actually collected to understand what kind of strategy they should deploy the next time when they want to do a particular campaign analysis. Now, in this picture, the interesting part is the Kafka layer as such. So initially, when they didn't have this part, they would be collecting. So the hard part for them would be to collect this data over a period of time and then actually do this computation. What Kafka brought into the picture in collaboration with DataTorrent RTS, so they could deploy it very seamlessly on DataTorrent RTS, and you have this running stream of data on which they are doing this in-memory computation. So what would take a day to give their end customers these metrics based on which they could actually change their strategy of how they should go about, so what imprints are working for them, what are not. They could actually now take that decision in just an hour or so. And then they could actually go ahead and persist this data on different stores. So later on, this persisted data could be used, or rather is being used for further analysis of how they can better improve upon serving their customers. Any questions so far?
What is the difference between traditional messaging system and Kafka?
So the question is, what is the difference between traditional messaging system and Kafka? So as I mentioned, in this particular webinar, we are not really focusing much on Kafka as such, but just on knowledge, what I could suggest is it's more on a publish and subscribe mechanism. So effectively, you are looking at a write-ahead log, which is partitioned and is available. So there is no attachment between the producer part and the consumer part. They are totally oblivious. And in Kafka, if I'm not wrong, you could actually even ask whether if I publish the data, can I get an acknowledgement back if the data was actually served to a consumer or not. So I guess some of these things are missing in the traditional messaging system, but there are other messaging systems which are equivalent to Kafka, which we can look at at a later stage. So there is another webinar where we will be doing a deep dive into this particular application template, Kafka to HDFS, which is happening on Wednesday, November 9th. So I guess there we will take up these questions which would deep down more on Kafka and related technologies as such. So let's move on to the second use case. Now this is an interesting one where one of our customers practically used Kafka for data at rest. So what we normally have seen Kafka, it's being used more in a streaming scenario where the data is continuously being played from the source side itself. Here, the interesting part is, so the need was a secure fault-tolerant data ingestion for some historical data, for certain logs, and some financial data which had customer data, which they had to serve with some processing in between to different end tier applications. Now, the interesting part is they were looking at this from different perspectives. So they had written something where this entire data would be collected and then provided to these applications. Then these applications would again then process this data and do this entire part which we see in between, the encryption, the compliance. I'll talk a little bit more about this in detail. So they ended up actually using the Kafka cluster in between, where they were just playing data at rest and providing it to a client which was reading this data, then encrypting this data. So there was a lot of sensitive customer data, and as part of the geography, none of this data could actually be served to the end stream applications as such, as an ASCII. So they encrypted, they masked this data. There was a compliance part, this algorithm which actually would check this entire encrypted data and also alert if there was any breach of the encryption for this particular data that would be served to the end applications. Part of this data was also archived so that they could always retrieve it back if anything goes wrong. And a fair bit of this data was again persisted on an Oracle store. So this was entirely done using Kafka and DataTorrent RTS. So all these operators that you could see, so the Kafka client operators were actually placed into the picture. And if I'm not wrong, an additional dedupe operator or other functionality was also introduced in this, where depending upon the different data from the financial part and the historical part, if there was any duplication of data, they would actually filter out the duplicates as such before they would encrypt and then pass it on to the compliance. So this was done seamlessly by this particular client of ours using Kafka with the DataTorrent RTS in a kind of a batch scenario. The third use case is primarily on real-time sensor data. So IoT, as most of us would be aware of, is the in thing these days. Everybody's been talking about it. So one of our big clients has been using Apache Apex or other DataTorrent RTS with one of their predictive maintenance platform, where they're actually playing data from their sensors through Kafka. There's a fair bit of governance that is involved over there. There's a complex event processing thing that they have written, which actually then does a fair bit of modeling. Rather, it kind of plugs into a model and provides a certain score to this data, which is then utilized by this predictive maintenance. The data then generated with the score is then provided or rather served to these end applications. And fair bit of this data again is being persistent for some ad hoc analysis that is being done by their other team as such. So effectively what's happening, so just to give you a particular use case that is happening at this particular client's place. So they also deal with aircraft engines. So some of these engines are fitted with these sensors. So different parts would actually emit a fair bit of data over a period of time. That data is being played through this cluster, provided to this through this complex event processing. And there's a certain bit of profiling that is being done for each of these uh, uh, components of the engine as such, where there's a certain score that is generated, and as a measure of the score, it kind of and certain rules that are written within the algorithm, that it provides them with a prediction layer which says, okay, this particular aircraft is in need of maintenance well ahead of time, before their aircraft engineering team actually goes and looks at the engine as such in their periodic maintenance. So well before that, they actually predict that there's something going to go wrong based on the data that they've collected, and this they could do as and when the data is being emitted by these sensors and being played in more or less real time using Kafka and DataTorrent RTS, and this data is being served for further ad hoc analysis to these applications. So instantly they could take an action where they would have taken a few weeks to actually figure out whether this aircraft engine requires maintenance or not, or rather they would have gone through their regular maintenance, but now they can see it kind of in real time. And then the other part of the data is persistently available for any of the data scientist team to do an ad hoc query. So are there any questions at this stage? Okay.
What is DataTorrent RTS?
So the question is, what is DataTorrent RTS? So DataTorrent RTS is an in-memory distributed data processing engine, which is, as we say, it is powered by Apache Apex. Apex is an open source platform that's available in the Apache Software Foundation. It is a native Hadoop platform. Basically, we need Hadoop 2.2 plus cluster in any mode, physical or virtual or on the cloud as such. So what this does is it's got inbuilt fault tolerance and scalability. So in collaboration with what we call Apache Malhar, there are these operators, what we call them as operators. So there are these business functions which are available. So you might want to read data from different sources. So it could be a messaging system like Kafka that we have seen. It could be an SQL store, so like an Oracle, an RDBMS store as such. It could be a NoSQL store. It could be any of the file systems, so NFS, or it could be reading from a HDFS for that matter, and doing a lot of processing on this particular data in an in-memory fashion. So we are not putting that data at rest. We are not writing it to disk. So in an in-memory, in a distributed, so you could actually write an application on top of this engine. So imagine these operators. You collect these operators, you place them as a Java package, and you run this Java package, rather the application, in a distributed environment on your Hadoop cluster, where some of these nodes could be just reading the data from sources. Some of the nodes in what we call the directed acyclic graph could be actually doing parsing of the data, then enrichment of the data. There's some complex algorithms that you could actually write as part of your own operator and deploy it in this Hadoop cluster as such. So it effectively utilizes HDFS for any persistency that we do. In terms of the scheduling, it relies on Yarn's scheduling power. So all the resources, the processing, the RAM, that is all taken from Yarn. So basically, the containers that are provided to our operators are provided through Yarn. So you could actually decide, you could just build this entire pipeline of these operators on top of Apex, which would actually run on top of Hadoop. So this is what is Apex as such. It's a true streaming engine, where the way we look at Kafka, for example, is nothing but a messaging queue for us, where we are reading data through a Kafka client based on the topic and the partition. And you could actually play this data in the pipeline and perform all your computations. So these computations, in a way, are given as operators as part of the Apache Malhar library. So coming back to why exactly us, why DataTorrent RTS? It is powered by, as I mentioned, Apache Apex. It's an open source top-level project. It's garnered a lot of interest in the ecosystem, and some of the big players who have been using us from different verticals, from the financial side, from the IoT space, from the ad tech world, totally in-memory processing, giving very low latency and the desired throughput that you would probably want. So high throughput and very low latency with built-in fault tolerance and scalability. So we basically ensure that so for each of these operators, so there's a concept of windowing where we actually go and checkpoint the data for the defined windows for each of these operators, and then we commit that data. So let's say if there is a crash, so let's say if some node goes down on the Hadoop cluster, or if your application crashes for whatever reason, Apex would bring it back from the last committed state as such. In terms of scalability, so depending upon the nature of data that is being played through the pipeline, if it's a lot of data, it scales out, and if it's less, it scales in as such, depending upon the scenario. So we don't hog your entire resources. So your infrastructure might need these resources for other applications as well. And it can exist in the ecosystem, in the Hadoop ecosystem with any other application. So Apache Apex could easily run with a Kafka cluster as such, or could easily run with an Apache Spark without any problem. And the ease of development that you get with this particular platform, all you have to do is you can take certain production-ready operators that are available as part of our Apache Malhar library, or you could write your own Java code as an operator and just plug them into this pipeline and build your entire application. So the way we look at data in this current scenario is, so be it a batch scenario or be it a real-time serving of the data to either your end application, or this could be your entire application where you process the data as and when the data is available. So you don't have to wait for the data to be collected anymore. You can just continuously keep on playing this data. Or the other part of the problem where people still have to collect data from different sources. So you might be reading data from a file system or from a store, or you might be reading data from a staged operational data warehouse and then play it into the pipeline. It could all be done very easily, where you just have to plug and play these operators as components into the pipeline.
So there are a couple of more questions. One of them is how you used it in a telecom use case, or is there any telecom use case which has been using Apex?
So in one of our prospects, I would say, they basically evaluated us against the likes of Golden Gate, where so there's a compliance need where they have to actually keep two sources, or rather two stores in sync. So based on an agent, they would actually read data, a change data capture kind of a thing, where they would continuously write this data to the next store. In another scenario, one of our customers, who's actually a large telecom player, is actually utilizing our platform for their billing application, where they collect data from different sources. So there's customer data, there's the transaction data for what services that they have used, and they actually rate the entire data. There are some sequence of these applications which are triggered in a batch scenario, and then the entire generation of the invoice, that data is served by on top of our platform to the invoicing application as such. So in a telecom scenario, this could be used for fraudulent activities as well, to look at the quality of services. For example, if you want to play this data on a regular basis as to whether a telecom player is providing the right kind of quality of service in terms of the service that a customer has taken, when you talk about something like a 4G, for example. So in all these scenarios, Apex serves very well as a true streaming platform.
Yeah. So there is one more question. What is how it compares with Spark and Stock? What's the difference?
So Apex, in comparison to Spark and Storm, so again, this session is not on that, but still I'll just cover briefly. Apache Spark has been in the ecosystem for a while. It's a pretty good platform when it comes to a batch scenario. So the way it handles data is more on a micro batch. So if people are familiar with the concept of RDD and micro batches, so the way it plays data is the analogy that I would say is, when you look at Apex, so let's say you're looking at a stream of flowing data, and you put two kind of markers in between the stream. So the markers will kind of follow the stream. Now that is true streaming. When it comes to Spark, it's actually, you are actually having, so imagine the stream as number of buckets kept one after the other, and you're putting water in all of these buckets, and that's how the water is flowing. So if any of these buckets go here and there, you have to again put them in the right order, and then again fill the buckets and play the data that way. So again, I won't compare the two platforms, but if you are looking at a true streaming platform, Apex is the one. Storm is similar. I won't say that there's any difference in terms of a streaming scenario, but in terms of operability issues, some of our clients have already utilized that, and they've gone ahead with Apex. So in terms of scalability and at the scale at which you would want to use such kind of platform for this kind of data ingestion and then the processing of it, it's huge. So Storm at times is not able to scale up to that particular level when you're talking about, hundreds and hundreds of nodes of Hadoop cluster as such.
So just taking that point forward, there's a question that what is the maturity of Apex or DataTorrent RTS compared to like Flink, Storm, and Storm?
So I'm not saying that because I'm part of DataTorrent, but looking at these three different technologies, and based on the feedback that we received from people who are utilizing it as of now, and who have actually done POCs with us, they have claimed that Apex, with respect to a true streaming scenario, is probably the better platform in terms of operability. So if you look at the fault tolerance, if you look at the scalability, if you look at the ease of development that it provides to the developers and the DevOps team, is far more enterprise oriented than any of the other platforms that are available in the ecosystem. So there is a case study which is done by one of our clients, Capital One. It's available over the net, and they have actually evaluated all these platforms, and they ultimately went ahead with Apex, where they got their requirement was to run 3 copies of the pipeline with 99.999% uptime, which didn't allow the application to go down at all, and they had to serve their customers with some sensitive data, and we're looking at a latency of 2-digit millisecond, early millisecond, but we ended up giving them like less than 2 milliseconds. So that kind of speaks volumes for the platform. So that's all that I had for today's webinar. If there are, I guess I've answered quite a few questions as of now, but if there are any further questions, I would like to take them now. In terms of resources, please feel free to subscribe to Apex. You can download if you want Apex, you can download it from the Apache site. If you would like to try out our RTS, which is the enterprise offering on Apex, which has got the visualization, the monitoring part of it, you can actually go to our website, DataTorrent.com, and you can download the recent version of it. The most recent will be coming out soon, which actually will have this app hub, which actually provides these app templates, which we are talking in these webinars. We have a meetup program where we conduct physical meetups in our headquarters in San Jose, and then here in India in Pune. Please feel free to visit us. We also have startup programs for newer startups that are there in the ecosystem and who would like to build their applications on a streaming scenario or any kind of scenario as such. It could be a batch as well. We have a particular license for them if they comply to the startup definition that we have provided. And for universities and for non-profit organizations, the license is available for free as such. And the next webinar is happening on Wednesday, November 9th. It's going to happen at 7:30 a.m. Pacific time. My apologies for the time that is mentioned on this slide. Actually, there was a little confusion due to the daylight saving. So those who are in the Indian time zone, it will start at 9 p.m. Those who are in the Pacific time zone, it will start at 7:30 a.m. Pacific time zone on November 9th, where our engineer would deep dive into this particular template where we read data from Kafka and write to HDFS.
Yeah, no further questions. Maybe we can just wait for a minute. If someone has any question, please feel free to type it in, and we'll reply back.
Sure. But thank you all for taking out time and for your patience to hear us out. So my email address is mohit@datatorrent.com. I'm part of the product management team as well as the partnership team here based out of Pune in India. If you have any queries with respect to DataTorrent RTS or what we are doing or what our clients are doing, any particular use case that you would like to discuss, or if you're interested in into the platform as such, please feel free to drop an email. Or likewise, if you have your engineering team, they can subscribe to our forum, users at apex.apache.org, and they can post their queries, and the community will definitely answer to that. If you're part of any startup organization who would like to utilize Apex or DataTorrent RTS, please feel free to just get in touch with us, and we'll help you out in getting the license for your startup.
Are there any sample POCs for hands-on? Maybe examples he's talking about.
So effectively, these templates that we are providing are kind of what you could use with your engineering team to actually do a POC on our platform. We do have certain demos on our site, and if you look at Apache Malha, there are quite a few examples that are provided over there as part of these operators, which you could download and play with them. But effectively, the newer version of our platform would provide this app up. So these templates could actually be seen as POCs, which could be deployed on your Hadoop cluster as such. Feel free to get in touch with us. We can help you out, and it's very easily deployable. So the entire documentation videos will be mentioned over there, which will take you through the steps, and you can easily deploy it.